Good morning, afternoon, or evening. How y'all doing today? Welcome back to Moro's Math Corner. Today we're going to learn about functions. It's just going to be an introduction, but we're going to learn a lot. So let's get right to it. A function is any relation, which is a set of ordered pairs, where each element of the domain, which are the x values, corresponds with exactly one element of the range. So in other words, it is a relation where there can only be one y value for any given x value. So I'll repeat that. A function is a relation where there can only be one y value for any given x value. Let's go ahead and investigate that with some examples. Let's determine if each relation below is a function. Well, I've got 1, 3, 2, 5, 3, 7, 4, 9. I don't have any repeating x values with different y values, so yes, this is a function. For my next example, I've got 1, 8, 2, 8, 3, 8, 1, 8. I do have two repeating x's, but they have the same y value, so yes, that is a function. My next example, I've got 1, 8, 1, 9, 1, 2, 1, 4. I've got repeating x values, but every single one of the y values for that x value is different. So that would be no, that is not a function. How about 1, 8, 2, 9, 3, 2, 1, 4? I've got a repeating x value of 1 with different y values, so that would be no, that is not a function, because I can only have one y value for any given x value. Example E, I've got 4, negative 1, 8, 6, 1, negative 6, 6, 6, 4, 1. Okay, I've got a repeating x value here of 4, but I've got a negative 1 y value for one of the x's when it's 4, and then I've got a 1 for the y value when x is once again 4. So I have two different y's for the same x, so this would not be a function, no. Then I've got negative 7, 14, 9, negative 7, 14, 7, 7, 14. I don't have any repeating x values with different y values, so yes, that is a function. When we're determining whether a relation expressed as an equation represents a function, we're going to want to follow this logic. When a relation is expressed as an equation, you must verify that there is only one y value, or output, for any given x value, input. Simply test one x value, and if it renders or gives two or more different solutions for that same x value, then it is not a function. So what are we talking about here? Let's determine if each relation represents a function. Well, we're going to follow the directions. We're going to choose one x value. Let's say when x is 1, for example. Let's solve for y. I've got negative 3 times 1 plus 2, so y equals negative 1. That's one y value for this given x value, so yes, that is a function. How about, for example, b? Let's go ahead and choose once again x equals 1. In this case, I've got plus or minus 4. So plus or minus 4 times 1 will give me two answers. It will give me y equals 4 and y equals also negative 4. So when I was given one x value, I got two different y values for the answer. So that would not be a function. No. Let's check the next one. For C, we're given y equals x squared minus 3x. So once again, let's follow directions. Let's choose a value of x. Let's choose an easy one, like x equals 1. Plug it in and solve for y. So I've got 1 squared minus 3 times 1. So y is going to equal 1 minus 3, which is negative 2. So let's investigate this. When x equaled 1, I got one answer for y, so yes, that is a function. For D, Let's go ahead and solve for y. Remember that in order to solve for y, we got to get y by itself. So I'm going to subtract x squared to both sides. So I've got 9 minus x squared equals y squared. Please remember that you get rid of a power of 2 by square rooting both sides. So you're going to have y equals plus or minus square root of 9 minus x squared. Why plus or minus? Because please remember that whenever you use a square root to solve, it must be in plus or minus. Okay, so now let's choose a y value, an x value, and solve for y. So let's go ahead and use x equals 1 again. I've got y equals plus or minus square root of 9 minus 1 squared, which is 1. So y equals plus or minus square root of 8. We remember how to simplify this. This is 2 times 4. The square root of 4 is 2. So y equals plus or minus 2 square root of 2. So when x equals 1, y equals positive 2 square root of 2 and negative 2 square root of 2. So I have 2 different y values for the same x. So no, this is not a function. And that's how you verify if an equation is a function or not. Let's learn about the vertical line test. The vertical line test helps determine whether a relation is a function. The vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. So when you're given a graph and they ask you to determine if it's a function or not, literally go ahead and draw vertical lines through it. If these vertical lines hit more than one value on the graph, then it is not a function. But here I hit the graph once, I hit the graph once, I hit the graph once. So yes, for any x value, I only hit one y value on the graph. For my second graph here, when I go ahead and perform the vertical line test, right off the bat, at this particular x, I've got 2 different y's. So this is no, it's not a function. Why? Because when I go through that particular x value, I had 2 different y values. Let's look at graph 3. I go ahead and randomly draw a vertical line through this particular x, whatever that value is. I'm going to hit the graph twice. So that means that I have 2 different y values for the same x. So no, that is not a function. How about over here? Graph 4. When I go ahead and draw a vertical line through this particular x, once again, I am going through 2 different y values. So that means that I have 2 y values for the same x. So that is no, it's not a function. Let's just go over some reminders. Please remember that a function is a relation where there is only one y value for any given x value. Please remember that the x values are known as the independent, the input, and the domain. Please remember that the y values are known as the dependent, output, or the range. And please remember that functions represent a specific equation or equations that do not alter. For example, movie tickets cost $15 per person. So a function can be written for that situation since it is constant. We will call y the total cost since y is dependent. It is dependent on the number of tickets you purchase. So we will call x independent since you can buy as many tickets as you like. And if you were to make a table here, okay, if you buy 0 tickets, you pay $0. If you buy 1 ticket, you pay $15. If you buy 2 tickets, you pay $30. That does not change. You can't buy 2 tickets and then your friend buy 2 tickets and have it be different costs, because then that would not be a function. Okay, let's identify the independent and dependent variables for each situation here. In winter, more electricity is used when the temperature goes down and less is used when the temperature goes up. So what's my independent variable here? If you said to yourself temperature, then you are absolutely correct. And what is the dependent? The amount of electricity used. Okay? Because the colder it is, the more you gotta use the heater. The colder it is, the more you have to use the AC. Okay? The cost of shipping a package is based on its weight. What is the independent variable here and what is the dependent variable here? Hopefully you thought the independent was the weight. And the dependent here is, of course, the cost. And it makes sense because the heavier the package is, the more it will cost to ship it. Next example. The faster Mike walks, the quicker he gets home. This is a tricky one. What is the independent variable here? If you said Mike's speed, then you answered correctly. And what is the dependent here? The amount of time it takes for him to get home. And let's think about it logically. The faster he walks, the less time it will take for him to get home. Last but not least, company charges $10 per hour to rent a jackhammer. Ooh, what's the independent here and what's the dependent? Well, if you answered the independent is the amount of time, or in other words, the number of hours that the item is rented, then you answered correctly. And the dependent is the total cost. Let's think about it logically. The more time or the more number of hours that you rent the jackhammer, the more it's going to cost. Now, let's investigate a function rule. A lot of times people get really stressed out and confused with this whole f of x concept. So let's hopefully wrap it up today. A function rule is an equation that represents an output, y value, in terms of an input value, which is x. You can write a function rule in what's called function notation. Shown below are examples of function rules. First of all, let's please remember that y is the output, and that y can simply be rewritten as f of x. F of x is just a fancy way of writing y. X is always the input though. X is always the input. So y equals 3x plus 2. That's the equation. In function notation, it would be written as f of x equals 3x plus 2. This is not f times x, my friends. This is read as f of x, or function f of x, or function f with the independent variable x. Okay? And now, how does this work? If I want to go ahead and find the value of the function when x is 1, I will write it as such. They'll say find f of 1. What does that mean? That means that I replace the x value with a 1. So once again, I replace the x value with a 1 in the equation. And of course, 3 plus 2 is 5. So therefore, f of 1 equals 5. How do I read that? When x is 1, y is 5. Hope that made sense. Okay, now let's go ahead and practice some plugging in here. Find f of negative 3. Well, f of negative 3 means that I'm going to replace every x with a negative 3. So my function here is f of x equals negative 2x plus 5. F of negative 3 would be negative 2 times negative 3, which is what I'm replacing the x with, plus 5. So that's 6 plus 5, which equals 11. So f of negative 3 equals 11. What does that mean? That means that when x is negative 3, my y, or my f of x, is 11. F of 0, I'm replacing every x with a 0. So I have negative 2 times 0 plus 5. 0 plus 5 equals 5. What does that mean? That means that f of 0 equals 5, which can be translated to saying when x is 0, y, or f of x, is 5. For f of x equals negative 4x squared plus 1, evaluate each. So I've got f of x. Well, what is f of x? Well, f of x is simply 4x squared plus 1 plus f of negative 2. So that means f of negative 2 is when I'm replacing the x with a negative 2. So I literally do such. So I've got f of x, which is negative 4x squared plus 1, plus f of negative 2, which is negative 4 times negative 2 squared plus 1. And now I'm going to calculate. So I've got negative 4x squared plus 1 plus negative 2 squared is 4 times negative 4 is negative 16 plus 1 is negative 15. And my final answer when I add like terms is negative 4x squared minus 14. And it's that simple. And last but not least, if I want to evaluate f of x minus 1, what did I replace the x with? Well, I replaced the x with x minus 1. So I'm going to literally replace the x in the function with x minus 1. And then I'm going to calculate. Let's please remember that when you have an x minus 1 squared, it's a perfect square. So first term squared minus 2 times the first term plus the second term squared plus 1. Now I'm going to go ahead and distribute, giving me negative 4x squared plus 8x minus 4 plus 1. And that will equal negative 4x squared plus 8x minus 3. And there you have it. Very simple. Whenever you want to evaluate a function, literally plug in the x that they replace for you into every x of the function and calculate. So let's go over some word problems here. Tickets to a concert are available online for $35 each plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. So that means that tickets are the independent variable. What function rule models the cost of the concert tickets and then evaluate the function for 4 tickets? Well, we know that x is the independent variable and x is the number of tickets. Remember to always label, it's going to make your life a lot easier. So the function f of x equals $35 for each ticket x plus a handling fee of $2.50. And if I want to now evaluate this for 4 tickets, I want to find f of 4. So I'm going to plug in 4 for every x and calculate. So 35 times 4 is going to equal $140 plus $250. So that's going to be $142.50. So that means that when x is 4 tickets are bought, in other words, the total cost is $142.50. You are buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase and then evaluate 15 bottles of that purchase? Okay, let's go ahead and see what we got here. Always label. X equals the number of bottles purchased. So the function is f of x equals $1.19 for every X bottle that you buy. It's that simple. So if I want to evaluate for 15 bottles, I've got f of 15 equals, I'm going to go ahead and multiply now, $1.19 times 15, and that's going to equal $17.85. So therefore, when you buy 15 bottles, your total cost is $17.85. And last but not least, in 2002, the Prestige oil tanker sank and started leaking oil off the coast of Spain. The oil slick took the shape of a circle. Suppose that the area A in square miles of the circle contaminated with oil can be determined by using the function A of t, so area is what the A stands for, t is time, which is independent. So A of t equals 0.25 pi t squared, where once again t represents the number of days since the tanker sprang a leak. Identify the dependent and independent variables. Well, the independent variable here, of course, is the number of days, the time that it is leaking. And the dependent variable would equal the area of contamination. Because the longer that the leak is leaking, that the tanker is leaking, the greater the area of contamination. And now let's go ahead and evaluate A of 30. What does that mean? Well, A of 30 means that I'm replacing the independent variable t with 30. So I'm literally going to replace t with 30, and I'm going to go ahead and calculate. So when I put this into my calculator, I've got 0.25 times pi times 30 squared, and that's going to give me, after 30 days, 706.86, if I round it to the nearest hundreds, square miles of contamination. And that is absolutely horrifying, but that's real life. Hope you learned a lot. Thank you for watching, and come back anytime. Take care now. Bye-bye.